Assalamu alaikum guys, welcome back. In the previous video we talked about the changes of ionization energy with the group. As you go up the group or down the group, how does the ionization energy change and why. In this video we are going to talk about how the ionization energy changes as we go across the period and why. Okay, so let's get started. Now ionization energy as we go across a period has to change. Okay, it changes because the factors that affect the ionization energy, they change. Okay, if you guys remember the previous lecture, I told you that there are mainly two factors that affect the ionization energy. The first one is the radius, okay, and the greater the radius, the lesser the ionization energy. And the second one is the shielding effect, right? And I've explained it in the previous two lectures what the shielding effect is. Shielding effect is the opposition provided by the inner shell electrons to the outer shell electrons to shield it from the nuclear attraction, right? Just a quick recap of that definition. So shielding effect, as well as you increase the shielding effect, the ionization energy has to decrease. And the third factor is nuclear charge, or the nuclear charge or the charge density. What is nuclear charge? Nuclear charge is basically the charge that is present on the nucleus, which in fact is actually the number of protons, the protons in the nucleus. Okay, the greater the protons in the nucleus, the greater the nuclear charge, because the nuclear charge is positive and it is due to the protons present in the nucleus. Okay, now the higher the nuclear charge, the higher the ionization energy, not less this time but rather higher. Unlike the other two factors, the nuclear charge increases the ionization energy. Okay, it has a positive relation. Now, so these are the three factors, the three major factors that affect ionization energy. These were changing in the previous lecture as well in groups as we go up or down the group of the periodic table, and they will change as we go across the period as well. So now let's get back to the lecture. Okay, so I've taken the example of period 3 of the periodic table. Period 3 of the periodic table starts out from sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine and argon. We have an entire chapter on period 3 in inorganic chemistry. Of course, we'll be doing that later on. But now this is just the period 3 that you have. Now, if we look at this period 3, the very first thing that you need to note is that the proton number. You have to note the proton number. What's happening to the proton number? The proton number is actually increasing as we go across the period. Okay. 11, 12, 13, 14 and so on, and it is increasing. Okay, so the proton number is actually increasing, so you have to mention that in your answer. Now secondly, what's happening to the number of shells of each of these elements? Okay, does this number of shells present in sodium, are they different from those present in magnesium? No, they are the same, because if you remember your O-level chemistry, we learned a rule that if the period number stays the same, the shells will stay the same. Okay, this is period 3 having 3 shells. Excuse me. If this was period 2, it would have had 2 shells. Okay, period 1, 1 shell. So the number of the periods present in the nucleus are the number of shells present in the nucleus. And now the number of shells is constant because it's the same period. If the number of shells is constant, so if you guys remember the previous lecture that we did on the groups, the changes in ionization energy with the group, I told you that the number of shells, they affect the shielding effect. The greater the shells, the greater the shielding effect, the lesser the ionization energy. The lesser the shells, the lesser the shielding effect, the greater the ionization energy. Over here, if the shielding effect is constant, the number of shells is constant, the shielding effect has to stay constant. So now you've come across two factors. Proton number is increasing, but the shielding effect is doing nothing, it's staying constant. Okay. Then the third one says the electron density, it shrinks. Of course it has to shrink, because if you are increasing the nucleus, the nuclear charge, basically by increasing the proton number, this proton number is actually increasing the nuclear charge, and the shielding effect is not doing anything, then the entire electron density around the nucleus, it has to shrink, because the effective nuclear attraction on each of those electrons, it increases. Okay, effective nuclear attraction actually means the nuclear attraction per electron, it has to increase. Okay, because the protons, the total protons in the nucleus are increasing. Okay, therefore electron density, if electron density shrinks, that means the radius is shrinking. Then comes the charge density. Okay, let me first explain what charge density actually mean. Charge density is actually a ratio. Okay, it is a ratio of charge to volume. Charge per unit volume is charge density. Remember what is density? Density is the mass per unit volume, right? Charge density is the charge per unit volume. Excuse me. So now the charge density, as the radius decreases, and the charge increases, what will happen to the charge density? Will the charge density increase or decrease? Basically, it is the charge per unit volume, right? The charge is increasing, so of course it has to increase because it's in the numerator. And what's happening to the volume? The radius is decreasing, that means the volume is also decreasing, and they are inversely related. That means if the volume is decreasing, again charge density has to increase. So there is actually a double effect of increase, okay, in here. So therefore charge density will also rise. And if the charge density rises, let me give you this relationship that the higher the charge density, the higher the ionization energy. Okay, this is also a factor. So the charge density is also one of these factors, although it is a combination of two factors, the radius and the charge itself. Where is it? This one. But still the marking schemes do award marks if you do mention the charge density as well. So to be on the safe side, you do need to keep this key term in your answer. Okay, a charge density, what's happening to the charge density in this case? It is increasing. Okay, it is not decreasing, it is increasing, it's going up. So due to all of these factors, the outermost electron of each of these elements, what's happening to them as you go across, as you go from one element to the other and from other to the other, what's happening to the outer shell electron? Will it become more tightly attracted to the nucleus or less tightly attracted to the nucleus? It's going to become more tightly attracted to the nucleus. Okay, more tightly attracted excuse me, more tightly attracted to the nucleus, because proton number is increasing, it's gonna attract the nucleus. The number of shells is staying constant, they are not providing any additional help, but the proton number is increasing. So electron density is shrinking. This also brings in the outer electron, it causes the outer electron to become closer to the nucleus. If the outer electron becomes closer to the nucleus, again it's gonna experience a stronger attractive force. And then the charge density is also increasing. The charge density, what it does is it also actually attracts the outer electron. The greater the charge density, the greater the ionization energy, because charge density actually means a relationship in between these two. So the greater the charge density, the greater the nuclear attraction on the outer electron. Therefore, the outer electron becomes more tightly attracted to the nucleus. More energy will be needed to remove the outer electron, and therefore ionization energy excuse me, ionization energy will rise. Okay, now so you must have seen the radii, how they are changing. Okay, all of these elements from sodium till chlorine, they have atomic radii. Okay, but the noble gases, they do not have the same radius as these elements, because their radius is measured using a different methodology. It's not measured using this methodology. Okay, remember in my very first video I told you that the radius is measured by taking a molecule and the internuclear distance is measured, and then the half of that distance is considered the radius, the atomic radius of these atoms. In case of noble gases, you don't have diatomic molecules, you only have monoatomic molecules, and in case of monoatomic molecules, you cannot have the internuclear distance. So therefore a different method is used to measure their radius, and it is measured using it is called the van der Waals radius. Okay, because that's a type of force present in them. We'll be talking about that later on. So since it's a different type of radius present in the noble gases, so it's going to be different from this trend. Okay, so it's an exception in this period. And this covers everything about all the factors. Now, guys, excuse me, if you are asked in the exam to describe and explain the trend of the, the trend basically of ionization energy going across the period from left to right, describe and explain for 3 marks or 4 marks. What are the different points that you are supposed to write, and what are the points that the marking schemes do award the marks for? So alright guys, so the first thing that you are going to mention is this one, proton number increasing. But this proton number increasing may or may not have the marks, okay? It's not that important, but still, to be on the safe side, you have to mention it in your answers. Then the number of shells is staying constant, so the shielding effect is staying constant. This is a single point, okay, and it carries a mark, okay? You must not leave it out. Then comes electron density shrinking and the radius also decreasing, so that's also 1 point, and that's what you'll get the mark for. This charge density is an additional point, okay? If it's for 4 marks, it will have a mark. If it's not for 4 marks, then it may be either or situation. Okay, either you write one statement or this statement, so you'll get the mark, or it may be an alternative statement. But still, to be on the safe side, I would suggest you write it down in your answers. 4 points, 4 marks, and then of course stating that whether the ionization energy will increase or decrease across the period, that will also have 1 mark. Although this is a 5 mark, you've got 5 marks in here on this board, but usually the question is for 3 to 4 marks, okay? So you may, sometimes the examiner does give you this this part as a hint. He tells you that the ionization energy, the first ionization energy, it increases as you go from left to right. Explain why. So this is the explanation. These are the points that you have to write in your explanation, okay? So in that case, this mark won't be given. And that's all about the changes in ionization energy with the periods, okay? After this, meet you in the next lecture regarding, this was ionization energy, then we'll be talking about atomic structure. Thank you.